Welcome to all of you. In this lecture, we are going to have the continuation of the timers from timer modes. So in the previous lecture, we had gone through the timer register and we had also discussed about the two registers TCON and TMOD registers. So in the continuation with the TMOD register, so we are going to have this mode control bits, that is M0 and M1 discussion over here. So this is common concept applicable for both timer 0 as well as timer 1, and these are mode control bits. So M0 and M1, so these are two bits always work in a combination, not individually. Therefore, combination of two bits, we are going to have four representations, that is 00, 01, 10 and 11. So 00, it is timer mode 0, where the timer is going to act like a 13-bit timer or the counter. In timer mode 1, it is 16-bit timer or the counter. In timer mode 2, it is 8-bit auto reload TL from TH register. Then 11, it is the timer mode 3. Then 2 8-bit timer by timer 0 only. Let's have more discussion on these timer modes. Now this is timer mode 0, where the timers are going to act like the 13-bit timer or the counter. Remember, this is applicable both for timer 0 as well as for timer 1. So let us first understand this block diagram. So in this, clock will be given to the TLX, that is the lower bit of the timer, that is only 5 bits. So then after, whenever TL overflows, it will be incrementing the TH. TH is 8-bit. When both TH and TX together overflows, then there is a rollover from the highest value to the 0. Then it is going to set the TF of the TCON register, which generates an interrupt. Now let us get into the theory of it. So here in the 13-bit timer, TLX is the 5-bit, THX is the 8-bit. Combination is what we are going to get, the 13-bit. So 5-bit in the sense it is a 32-bit count, or we can, in the another sense, we can say 2 to the power of 5. We say that is equal to 32. Whenever TL is going to count the value 32, then there is a rollover of the TL which increments the TH by 1. So we say that TL is in frequency, it is divided by 32. So in this mode, the total count possible, that means combination of TL and TH in combination, the total count value possible is equal to 2 to the power of 13, that is equal to 8192. Right? Remember, this 13 is nothing but how many number of bit timer it is going to work as. So that's what the value we are going to have. So here it's a 13-bit. Therefore, here also the total possible count value is 2 to the power of 13, that is 8192. So if we consider an assumption that we are going to use an oscillator of 12 megahertz, then what is the possible delay that we can generate using this timer mode 0 is being represented here. That means maximum delay in one complete rollover. That's what the delay we are going to calculate here. Remember, in case of 8051, the frequency will be internally, it is divided by 12, that is going to happen. So that's why this divided by 12 is always a common representation irrespective of the whatever the oscillator value or whichever the mode of operation it is. So this is always divided by 12 operation that is going to happen internally. Therefore, we must consider this divided by 12 concept whenever we are calculating the delay. So now the maximum possible delay will be equal to total count value multiplied by 12, that is divided by 12 concept, that is 12 divided by the oscillator frequency. So oscillator frequency, here we are going to make a assumption that it is 12 megahertz. In such a case, it is going to generate a delay of 0.00898192 seconds. So that means if once in timer mode complete 13-bit counting it is going to happen, then at once it generates this amount of delay. Now let us get into the timer mode 1. So this diagram is more or less common in all the timer modes. So let us first go through this. So in this timer mode 1, so it is going to act like a 16-bit timer or the counter. So that means both TL as well as the TH, both all the bits it is going to consider. So that's why complete 16-bit timer it is going to act like. Now clock first goes to the TL 8-bit. Then after every rollover of TL, TH will be incremented by 1. Complete TL TH combination overflow or the rollover. Then TF of TCON register will be set, which generates an interrupt. Now let us go through the theory of it. So TL 8-bit count, TH is 8-bit count here. So total combination is what is going to generate the 16-bit counter. Right? So after every 256 counts of TL, that is 2 to the power of 8, TL is 8-bit, therefore it is 2 to the power of 8, which is nothing but 256 counts. So TL is going to roll over, which increments the TH by 1. So if we consider the combination of both TL and TH, then it is equal to 16 bits. So total count possible from this timer mode 1 is 2 to the power of 16. That is 65,536. So what is the total what is the maximum delay now possible to create in this timer mode 1 if once complete count operation happens? That will be equal to count value, that is 65,536, into this 12 is the divided by 12 concept, that is a constant value. Oscillator frequency, here we are going to assume 12 megahertz. Now substitute, simplify, we are going to get 0.065536 seconds of delay from timer mode 1. Remember, again it is once if it counts the total count value, that is 0 to 65,535, that is total 65,536 value. Once if it rolls over, then it is going to generate this amount of delay. Now let us get into the timer mode 2. The timer mode 2 is 8-bit auto reload from TL from TH. So in this case, as we can observe over here, so TL is the only counting operation that is going to perform. It is not in combination with the TH register. So whatever the initial value we want to load after every counting operation, so that value to be reloaded will be available for us in the TH part of the register. Right? So clock will be given to the TL. TL is a complete 8-bit timing, the counting operation is going to perform. So it is complete 8-bit. So once there is a rollover, then it is going to set the TF of the TCON register and an interrupt will be generated. Along with that, there will be a buffer like representation here. So whenever a rollover happens, then whatever the value we again want to reload to TL register will be previously stored to the TH register, that will get reloaded to the TL. So manually every time it is not required to be loaded to the TL. So once we load to the TH, automatically in this mode the TL will get reloaded again. So this is a typical 8-bit operation or the 8-bit timer it is going to work like. Getting into the theory of it. So TLX increments on every count. Then when TLX rolls over from FF to 00, then TFX will be set and provides an interrupt. Then TH will reload the TL. Right? So then what is the maximum count value possible out of it? So since this is a typical 8-bit representation, so it is 2 to the power of 8 is the possible count value, highest value. So that is 256. Now how much delay we can produce out of it? So same formula we are having. So count value, then this is divided by 12. Oscillatory frequency we are assuming it as 12 megahertz over here. Then this is what the delay we can get out of this mode of operation. And let us get into the timer mode 3 operation. So in the timer mode 3, so it is 2 8-bit timer by timer 0 only, right? So now in this is a special case. So clock TL0 is an independent 8-bit counting operation is going to perform, or the timer operation is going to perform. Whenever there is a rollover in the TL, then it is going to set the TF0. Then clock will be given to the TH0. Again, this is a typical 8-bit. So whenever TH0 overflows, it is going to set the TF1 of the TCON. So why it is a little bit different? So see, timer 0, it is related to TF, that is fine. So this is again TH0, this belongs to timer 0, but it is going to set the TF1, which usually refer to the timer 1 overflow in the TCON register, right? But in the mode 3 of operation, so this is a special case where when TH0 overflows or rolls over, then it is going to set the TF1 flag. Go through the theory. So TL0 and TH0 are used as two separate timers. There is no connection between these two, they are totally separate. So TL0 gives interrupt to TF0 flag bit of timer 0. TH0 gives interrupt to TF1 flag bit of timer 1. Then TL0 can be used as either timer or a counter, whereas TH0 must be used only as the timer. Right? So one thing to remember here, so in all these timer mode, we have considered that the oscillator frequency is 12 megahertz. But while giving the question or the calculation, there is nothing like it is fixed. 12 megahertz is a fixed concept. No, it is not a fixed concept. So it can keep varying 22 megahertz or 11.0592 or any value that has been given as the oscillator frequency. That value we have to consider in order to calculate the delay value. Thanks for joining.